Today we are going to be looking at the molecule named 1-iodohexane. The CAS number for this molecule is 254-95925. The molecular formula for this compound is C6H13I, which tells us there's 6 carbons, 13 hydrogens, and 1 iodine. We can see that the degree of unsaturation is 0, which makes sense because we don't have a pi bond or a ring. And the functional group involved in this compound is a halogen iodine. The molecular weight of this compound is 212.07 grams per mole. The melting point is negative 75 degrees Celsius and the boiling point is 179 to 180 degrees Celsius, which tells us that it is a liquid in room temperature. So in total we have 19 sigma bonds in between 7 sp3 hybridized atoms. To build 1-iodohexane, we will be using the Snatoms kit, which looks something like this. We can see that different colors are used to represent different atoms. White is used to represent hydrogen, whereas the black is used for carbon. Going back to our molecular formula for 1-iodohexane, we know that we need 6 carbons, 13 hydrogens, and 1 iodine. Now, using the Snatoms model kit, I can grab my 6 carbons, 13 hydrogens, and 1 iodine. Before we start building our molecule using Snatoms, I want us to have an idea of how the 6 different carbons are connected and how the functional group iodine is connected within the carbon chain. We only have one substituent, which is the iodine. Using the Snatoms, I want us to be able to identify the methyl, the methylene, and the functional groups easily and count the number of sigma bonds in this molecule. Now that we have all the Snatoms that we need, I can finally start building my molecule. First, I'm building a methyl group, which is just a carbon with 3 hydrogens attached to it. I will start by building a hexane first. So for that, I need 4 methylene and 1 more methyl group. But to make 1-iodohexane, we will be substituting 1 terminal hydrogen from one of the methyl groups with an iodine. Now, because there are sigma bonds between the carbons, I am able to rotate the bonds about an axis. Now that we have the parent chain that we need, we can start thinking about the substituents. Our substituent is iodine. That's how we get the name 1-iodohexane. The 1 in the 1-iodohexane tells us where the position of the iodine is. It is in the carbon 1 position. It could be either the carbon from either ends. It could be this or this. For me, I will just snap it on this side. Using our 6 carbons, 13 hydrogen, and 1 iodine, we have our final product, 1-iodohexane. The structure that I've made here is the same structure that we made using the Snatoms. So it is easier to see how many methyl groups are there. 1. And the methylene groups. And our functional group is a halogen, which is iodine. Find the number of sigma bonds, it is easier to write down the structure like this, and each line that I've made is a sigma bond, so we can see that there's 19 sigma bonds in this molecule. So with that, I hope this helps everyone understand the structure of 1-iodohexane and Snatoms a bit better. Thank you.